Here is our demo environment. So we have a quote unquote on-prem. It's really just a couple VMs running in a local vSphere here. We have an SRX on the edge. Then we have some resources in AWS. So we have one server each in two different subnets. We've got a trust network and a DMZ network where we have our web and DB servers. These are the tags we have on these resources. So these are VMs. This VM has Department Finance, tier web, and then we have another one in a different subnet with Department Finance and tier DB. And then in Azure, we have another pair of VMs. So a web and DB in a different department, in the HR department. So what we're going to try to demonstrate here is first using tags to actually push security policies to these cloud environments. So both of these SRXs, which are securing traffic between those cloud instances, are going to get policies based on these tags. So we're going to create a policy that allows traffic within the finance department from the web to the DB tier. So like this. We're going to create another one within HR that allows web to DB traffic. We're also going to create outbound policies to allow this web server to reach out to the internet, maybe for automatic updates or grabbing static resources from a CDN. We're also going to add a policy so I can actually access these from my little VPN. So let's take a look at what we actually have for those resources already. All right, so in AWS, I have my database server, my web server. We take a look at the details of any of these. Let's look at my DB instance. If I go into the tags, you can see I have keys for app, department, name, and tier. For this example, I'm using the department and tier tags. There's also a tag I'm going to want on my SRX. Specifically, this tag is going to tell Policy Enforcer that this is actually an SRX appliance and that it should actually discover it inside of Security Director. And we'll see the same things over here in Azure, the DB server, and under tags, you can see I have the same set of tags here. So I have my department, name, tier, and app tags. Of course, we're only using two of those, but we could create additional policies that match on any of those available tags we like.
One question for AWS, is this single VPC?
I'm sorry, can you repeat that?
Is this only for one VPC or can you do multiple VPCs?
You can do this across multiple VPCs. Yep.
Yeah, one of the things that Josh didn't show here was the kind of, we have, like, the way he set up this whole environment is completely scripted and automated using like CloudFormation templates.
Yeah, I'm using Terraform for this one.
Terraform.
Yep.
Yeah.
Yeah, and that's really one of the advantages of moving to the cloud is automation gets a lot simpler when you're using a well-known set of public APIs, which there's a ton of documentation and great libraries. So I've already discovered these devices in Security Director. I spared you that part because it takes some time, but I've discovered my AWS and Azure instances. In order to do that, all I had to do was create a connector. So each of these, I create a service principal in Azure and an application credential token in AWS. I put that information into here, and then Policy Enforcer is going to reach out to those endpoints, grab all of my my VMs. It's going to identify my SRXs, so I tell it which tag to associate with SRXs, and then it will automatically create discovery jobs to find all of my cloud instances. I've also already enrolled these devices in SkyATP. Let's take a look at that. Or yeah, ATP Cloud. Some old terminology. So you can see I've added my ATP Cloud realm here. I've enrolled my devices. And then I've created a threat prevention policy, which I think is actually worth looking at really quickly. So inside of a threat prevention policy, which is where I actually, on the SRX, say, this is the traffic I want to inspect, and this is what I want to do with it. I can set a threat score for my CNC policy. So when the device contacts a CNC server, it'll be assigned a threat score. I can decide what I do based on different threat scores. So in this case, from 8 to 10, I'm going to block that. Then I can include my infected host policy, where I can decide what I do for hosts that have been flagged as infected. In this case, I'm going to take the quarantine action. Now, this tag here has a couple different purposes. If we were enforcing on firewalls, this is a quarantine VLAN. So I'm going to put it in an isolated VLAN for remediation. In the cloud, this is actually the name of a security group. So in both AWS and Azure, I have a security group that just has no rules. It blocks everything. So the way this is actually going to be enforced is just using the AWS and Azure security models by moving that VM to a security group that blocks everything. In this case, one called quarantine. And then I'm just going to connect to my feed type. You can see the version I'm using calls this Sky ATP. That's our cloud ATP solution. All right, so let's go ahead and deploy those policies. Right now, I deploy these with any policies, so we don't want those. So just remove those. And we don't really have time to spend too much energy going through all the details of this GUI, so I'm going to go through this fairly quickly. So we're going to call this cloud policies and enable logging, and then add my 2 cloud instances. And now we're going to add some rules. So first, I'm going to add my HR Web 2DB rule. And instead of matching on zones, which I can certainly do, they're in the trust and DMZ zones respectively, I'm just going to match on metadata tags. So even if I modify my zones or it gets spun up in the wrong zone, I can actually apply the same policies to it. So for the source for this policy, I'm going to specify policy enforcer as my metadata feed provider. And then I'm going to apply a filter. I want to match HR department traffic that is also from the web tier. And you can see it figures out which IPs actually meet those qualifications. We'll do the same thing for my destination. So same department, but now the application tier is going to be my DB tier. We're going to permit this, and we'll go ahead and reference our threat prevention policy here as well. So any of this traffic is going to be scanned. All right, while it's provisioning that, I'll create my finance rule. New zone. I'm going to go through this fairly quickly because we are a little short for time. So we're going to do the finance department. Web tier is our source. Again, these IP addresses are dynamically updated as VMs are provisioned that match those tags. And we'll do the same thing for our destination. The department is finance. And the tier is the DB tier. Going to permit and scan this with my block malice threat prevention policy. And lastly, I need a couple other quick rules. We're going to allow outbound. This will be from any zone. We're not going to use any address matches here, just to enable internet access. So I can download some malware in this case. And lastly, I need a policy so I can actually access these instances over my VPN. These are all tied together with a full mesh of IPsec. So I just need to allow inbound from my VPN zone.
And so can you create rules from like the CLI or SSH or something that you can automate the rule creation?
So for the dynamic address group specifically, those need to either be created through Policy Enforcer, or we do have a set of APIs for this. So you can automate it in that respect. You can write a script that uses the Policy Enforcer APIs to script this process. But the dynamic address groups specifically aren't something you can just hammer in through the CLI because they need to be tied to Policy Enforcer.
Yeah, the policy enforcer does have, so the easiest way to describe it sometimes is as an API gateway. So we have a number of connectors, like the ones to cloud instances, the ones to different NAC vendors, things like that, that are already kind of built in. But we also have customers that have built their own connectors for whatever it is they're using. And the API is it's really just using a bunch of scripts under the covers. So you could actually automate the entire workflow without using, like, if you didn't want to use, like, say, a GUI tool. It's just a little bit more complicated.
Yeah, it's all just a set of REST APIs here. So if you do want to automate it and avoid the GUI, that's certainly something you can do. All right, so we've defined our policies. So we have one matching on tags that allows HR traffic from web to DB. Similar policy to allow finance traffic from web to DB. We're going to allow outbound internet access for all instances. In reality, we'd probably want to restrict it to the web instances. And then inbound on my VPN so I can actually log into the things. So I just hit update. So I think I did. Let's make sure I did. This is going to now publish the security policies to those devices. It's also going to create the dynamic address groups. So now the SRX is going to be periodically receiving an updated list of addresses that match each of those tag policies from the policy enforcer, and using those to actually apply our security policies. So now let's take a look. And it looks like my session expired while we were chatting. It does tend to happen. All right, so let's go ahead and hop on to my AWS instance. And take a look at my configuration. So here is the policy that created. It's actually several policies. So you can see in my HR web to DB policy, in my match conditions, I'm matching on these source addresses that say policy rule DAG. DAG here stands for dynamic address group. So these are the values that are actually being populated by my policy enforcer based on those tags. You can see in my action, I'm applying my SecIntel and advanced anti-malware policy. So I'm going to be scanning this traffic for malware. See, we have a similar policy created for finance, and then my outbound and VPN policies. And we can take a look at my dynamic address groups. So right now, you can see, for instance, the DAG1 group does not yet have any entries in it. Same for DAG2, 3, and 4. It will take a couple minutes for these to propagate. So there are several stages where it has to get pushed from one service to another, and there are timers at each of those. So this will take a couple minutes. You can actually test this by just trying to ping one of those. All right, so it looks like at least my outbound policy is working. So we're going to jump onto my AWS web tier instance. And we're going to try to ping the DB tier, because that is the traffic we are allowing with those dynamic address groups. So it's going to take a couple minutes for this to actually push. So this actually be a great time for any questions.
Are you gonna look at the change management section? Does that show like when policies are changed, or?
So the change management workflow. So within the security director, right, software, for certain, you can go, like, we're kind of doing it in a lab environment, so everything is just going through. You're allowed to kind of create whatever you want. But for a lot of organizations, you may have, somebody that creates the initial policy and then somebody else who has to actually approve it before it gets pushed. Mm-hmm. So that's what that change management kind of workflow does, is it will alert, maybe the firewall, engineer, right, creates the initial policy, and then their manager has to approve it first.
Yeah, we don't have any of that set up in this environment right now.
Hey, Josh, these rules look like they're set up by name. And if the name were to change or be renamed, would it break the rule? I'm just curious versus like if it was established by a GUID or something along those lines.
Are you talking about these names here?
The names you showed on the last part, but basically all these things look like they're static, numerical potentially case-sensitive variables. Are they case-sensitive? If you were to, they are case-sensitive? Okay.
Yeah, everything's going to be case-sensitive. And if you were to change, say, one of the tag values, then you're going to end up affecting what policies are actually applied to that resource.
Yes, I would think we would. That's why I asked. Thank you.
Yep. All right, so you can see now this traffic is going through. So let's talk just briefly about what just happened. So if we go to my topology again, we created a policy allowing this flow of traffic. So from my, actually blocking my screen a little bit here, from my finance web server to my finance DB server. And this was done just based on the tags applied to those resources. Now, you can see traffic is flowing between those resources. And if we now take a look at my dynamic address groups, you can see this group here, group 3, now has an entry. If we take a look at my policies, that comes from my finance HR to DB policy. So that's matching on this source address. And we can also take a look at that actual address group. You can see right now, it contains just a single IP. If I were to go spin up other VMs that match those same criteria, they're going to be added to this dynamic address group. So this will be updated. There's a couple minutes lag, but this will be updated more or less in real time. I want to also confirm really quickly that traffic is not flowing in the other direction because we did not allow that. So we're going to log into our DB server. And we're going to try to ping the web.
The tags, yeah. So you abstracted this and you deployed it to AWS and some other SRX devices, yeah?
Mm-hmm.
How would it be? Is it always deployed to all of your devices or just to the devices that actually have something that is using that tag?
Good question. It only goes to the devices that actually have something that's using that tag.
Oh, great.
Yep. And we're a little short on time. Otherwise, I would show you this in Azure. You'll just have to believe me for now that it's doing the same thing.
So actually, a question, how does this work with mobile users? Like I think of MDM, I think of VPN, client-based VPN. This is a good example of brick and mortar, but how does this implement towards like a mobile workforce?
So are you talking specifically about, say, you have like a mobile remote access policy and you want to allow specific sets of mobile users access to resources?
We've moved home due to a global pandemic, and I'm accessing resources from my newly built home office that I've exposed some services to internet or have them through some sort of remote access VPN client. There's a few scenarios here. I'm looking to get an idea of how that would function in maybe a scenario or two.
Yeah. So these policies we're looking at here are geared primarily at inter-cloud communication. So communication between your resources in the cloud. These are going to be not quite as easy to implement if you're talking about remote access from, say, a public IP. This is definitely more about securing communications between, in this example, my web server and my backend software.
I mean, one thing you could do, right, is depending on, again, how you want to structure things. Again, you have maybe now all of your app developers that actually need access to these resources are now working from home, right? You could backhaul all the traffic, right, to your main data center and then up to the cloud. And that's kind of what the full mesh VPN has done. So that's one way of accessing it, but it's not very efficient. You're adding an extra latency. It's just usually not great, right, when you're trying to SSH to multiple devices and jump through multiple hoops. So the other thing you could do is, because you do have a fully functional VSRX running in each cloud instance, you can use a VPN client to then allow, say, just your developers to access that individual VPC based off of that.
Yeah. So if you just wanted to use the SRX as a VPN endpoint, that would apply as well.
Okay.
All right. So I'm going to go ahead and I'm just going to start this because it's going to take a couple minutes and we can address that. I'm going to go ahead and download some fake malware here. So from my web server, I'm going to download the EICAR file, which I'm sure you guys have seen. That is going to cause this host to actually get flagged as infected. And we can see this host will get isolated within a couple minutes. And I'm sorry, it sounded like there was a question before I interrupted.
I did have a question regarding once you have these tags established and such like that, you can slap that stuff into JSON or YAML for easy deployment and use, basically, correct?
Yep, absolutely.
So with that said, can I then apply these rule sets in an easy fashion to Kubernetes services, containers, so on and so forth, effectively?
In principle, yes. There is not an integration with the policy enforcer component specifically with Kubernetes. So I can't go down to like a Kubernetes cluster and create some Calico policies or something like that. That doesn't exist yet. That being said, policy enforcer does have a connector right now to our Contrail SDN system, which does have Kubernetes integration. So there's an extra hop there, but you could integrate those Kubernetes tags through Contrail in that way. But you have that extra component of Contrail that would be involved there.
Okay, cool. So if I wanted to then tie those pieces in together, or leverage in my service mesh for security between endpoints and fill in blank of Nginx and all the little pieces that I need to do, Contrail might be the bridge for that, or maybe that's something developmentally coming in the future to provide that deeper integration for my containers. Yeah.
So Contrail in this context basically acts as your CNI plugin for Kubernetes. It handles the actual networking and policy enforcement. So you could take that, if that's what you're using as your container network interface, and plug that into policy enforcer, and then you'd get what you're looking for there. Yeah, it's pretty cool. All right, so we've infected our host with this horrifying EICAR file. So you can see it now shows up in my infected host in SkyATP. That's this line right here. So my 10.0.1.10 host. If I click on that, I can then see, actually we want to see really the actual download. So I can go to that event and I can see some details about what that host actually did. So I can see the naughty behavior this web server's been up to. So threat level 10, I can see the prevalence of this threat. A lot of people use an EICAR, of course. And then further down, I can see the results of my behavior analysis. So what types of risky behavior that application exhibited. Network activity, hasn't actually done anything because it's just a text file. And then behavior details, I can see what that file actually tries to do when we've done an analysis on it. Now I want to go take a look and see if my host has been blocked yet. Oop. Typing is hard. There we go. So currently it is not yet blocked. Just takes some time because of the timers for this to actually propagate down to my my cloud environment where this will actually end up getting blocked. Let's see. Any other questions while we're waiting on this? Or Crystal, anything else I should point out in this interface?
Do you want to go over to like CNC servers? So this would be one of the other kind of indicators that we use with that host analyzer function. So if that host was also reaching out to a botnet or CNC server, you'd see those hits there. If you go to the configuration, we could also do things like taking a number of third-party feeds that you just enable with a one-click kind of easy button. So like the malware domain list, right, or DShield. If you click on go to feed site, it's just we kind of automatically, you click on that little checkbox, and now that will be sent as one of the CNC feeds that you can then use to block traffic on your network through the SRX. So there's a number of third-party feeds as well as the feeds we provide directly, and then there is an API. So if you wanted to, say, integrate some of your own feeds, maybe there's a number of companies who specialize in just security intelligence feeds. There's also specific feeds that are provided like through ISACs for specific industries. So through the API available within the ATP cloud, that's another option, right? You can start to use that information to integrate this and be able to leverage the intelligence you're getting to actually do some remediation and blocking.
Yep, and there's a lot of flexibility with third-party feeds. So there are these pre-configured ones. You can also just create a text document and feed that in. You can have an API that just responds with a list of blocked IPs. You can use as your own custom feed as well.
Yeah, it's like the idea of just having like a list on a server. Again, that could be a list that your analysts, right, in the SOC kind of collate their data and provide a customized list for that.
Can I also extend it to Stix feeds, for example, or Hele Taxi? And can I also go retrospective? So, for example, malware was embedded in a software update and being silent for 2-3 months, and then go back in time to check whether that malware, where that software was downloaded and being active, like 2 months later.
Yeah, so you can kind of do some of that here, right? It'll depend exactly how far you want to go back. For like retrospective analysis and seeing, like we have that global prevalence counter that will look at stuff over time. But for a longer period, you might use something like a SIM tool, like we have JSA. We also have some analytics capability within the ATP appliance as well, so that for longer term kind of correlation. As far as Stix Taxi goes, you can see there's a download Stix report up there for each individual piece of malware. And then if you go to the actual configuration section, Josh, or the administration, sorry, we actually do provide, oh, maybe I'm wrong, where it is in the UI. We actually have the
You might
option.
be thinking of the new version.
Yeah, I probably am. I think maybe it's under configuration. Then there is a option to create threat intelligence sharing, right? So what we'll initially do, right, is enable Taxi, so you can actually share the threat information you're getting from this service with other ones. So like we have some built-in integrations with endpoint, some endpoint response like Carbon Black, where we can ingest the IOCs that Carbon Black might have found from a specific type of malware, and see, again, we'll use those as part of our ability to kind of then add maybe that host to the infected host feed to be, again, quarantined on the network. We can also share the IOCs that we find with Carbon Black, and so Carbon Black being an endpoint protection for things that have not come over the network. We could potentially see if those IOCs also exist on another endpoint, or 100 other endpoints, and then take some remedial actions based on that.
Yep.
Hey, did we miss the part where you go into encrypted traffic analysis? I just want to make sure I didn't miss that.
So,
Great question.
actually,
That's next.
I was going to say, maybe we should jump into that now, Josh, because we're going to run out of time. And we'll come
I was going to say the same thing. So it actually just blocked. So my ping died. In fact, my SSH connection died because it's now fully isolated. If we take a look on my SRX, difficult typing with the keyboard at my waist. So you can actually see my infected host feed now includes that host. And if I go to AWS real quick, you can actually see how that was accomplished. So if I look at my web server now, in my security groups, oh, it hasn't actually updated the UI. What we should see here is it actually now belongs to the quarantine security group. Yeah, so now it's in the quarantine security group. And this is how the actual enforcement in the cloud happens. We're actually taking advantage of the existing resources, like in this case, security groups that just deny all traffic. Okay, so that's it for me. Now we can hand it off for ETA.